Welcome to this video on S2. Today we are looking at continuous random variables. Now, a continuous random variable can essentially take any value, an infinite many values. The probability though that it takes just one value is always going to be 0. So what we need for this is essentially a range of values when we're looking at them. Now what we're going to use is what's called a probability density function, or p.d.f for short. And this will be used to define the probability of a random variable taking values within a given range. And what we kind of get is we essentially set up the p.d.f as a graph, and we want to find the area underneath that graph. So, once we start looking at these, it'll be a bit more obvious, but we could have a p.d.f that could look something like this. It could create this kind of graph between, say, a set of values of x. And what we can do is we can find the area under that graph between two specific values, and that will give us our probability. So the probability is going to be that area under the graph. Very much like when we did a normal distribution, which is also a continuous random variable. And when you looked at values there, it was always about the area under that graph, wasn't it? That was the probability. So this is essentially the same thing, but that graph is no longer going to necessarily look like a normal distribution. It could look like all different types of graphs. But all the graphs it's going to look like are going to be ones that are familiar to you. So imagine that x is my continuous random variable. Obviously I can use other letters like y. X is the most common one, so we'll stick with x for this one. So it's a continuous random variable with probability density function f of x. So the first thing is that f of x is always going to be positive. So this will be for all values of x. Okay, so probabilities must be non-negative. The second thing then is the area under the p.d.f. That's what you're going to find your probability. So if I want to find the probability between two values, a and b, then that's going to be the area under the graph between a and b. So all that would mean is that I would integrate between those limits. And then the final kind of condition, I suppose, or rule, is that the total area under the graph must be equal to 1. Because we know that probability will always total 1. Okay? Now that we've talked about this bit, it probably still doesn't really make sense to you at the moment. But don't worry, let's look at a couple of examples. That's when things start to make a little bit more sense. So first let's look at, what this p.d.f is. So we've got a function here, this first one. We've got my f of x is between 0 and 3. And this 0 otherwise means that there's no probability outside of this. So this is the graph, but only between these set of values. Now if I look at, say, sketching this graph, what that means is at 0, my first value is going to be 2, isn't it? Because if I substitute 0 into here, I get 3 times 0 plus 2. So it's going to be 2. Now when I look at the top value, because this is linear, I can just do the bottom on the top value. So when x is 3, 3 3s are 9 plus 2 is 11, isn't it? So at x equals 3, say, my value up here is going to be 11. Now it's just a sketch, so it's just something like this. And if I look at it, obviously this line would go on in both sections, but it's just between 0 and 3. If I look and I want to find, say, the area underneath this graph, well, what I've got is a trapezium, haven't I? So finding the area under this graph is going to be, here's my A and my B, and that's the distance between them, isn't it? So we've got 2 plus 11 over 2 times by 3. And that gives me an area of 19.5. Let's put units squared. Now that area is obviously not 1, isn't it? 19.5 does not equal 1. Therefore, not a p.d.f. Now let's look at the second one. When I'm looking at the second one, I've got this k, this constant. Okay, so if I'm looking at this constant and I'm going to draw this graph, again it's going to be linear. You know, you've got 4k minus kx, so it's going to be a linear graph. So let's start first at the minus 2, and this one I'm going to do in a slightly different colour, just so that it stands out from the one above, for no other reason. Okay, so if I substitute minus 2 into here, we get 4 minus minus 2, so 4 plus 2 is 6, that's 6k. So this is going to be, say, here at 6k, and then I can put in 0. I'll do all the way across. I'll do 3 values. Just put 0 in. 4 minus 0 is 4. So that's 4k. It's going to cross here at 4k. And then at a positive 2, you can see 4 minus 2 is 2. So that's going to be 2k. So, you know, down here, 2k. So what I get is, I should get a straight line there. Let's put it that way. And there we have our graph, our function. Okay, now notice it's in terms of k, and that's perfectly fine. But for this to be a PDF, the area underneath must be equal to 1, isn't it? So if I first find the area of what I've got in terms of k, again, I've got a trapezium, haven't I? So that area is going to be my A and my B. So A is going to be 2k and 6k. So 2k plus 6k over 2, multiplied by the distance between them, which is 4. And that will give me 16k. So the area under this is 16k. So for it to be a PDF, so for it to be a PDF, that area of 16k must equal 1. Therefore, k would equal 1/16. So if this was to be a PDF, k would have to be 1/16. Any other values of k would mean it's not a PDF. Hopefully that makes sense. Now, just moving it up so that I've got a bit more room, let's look at our third and final one. So we've got a function between 0 and 3. Now, when I look at this one, we've got what was basically 2x minus x squared, isn't it? So we know it's a quadratic. If I look at the points, it's going to turn. It's going to be at 0 and at 2. So we've got a graph that looks like this. And then after the 2, it's going to carry on down. Let's put the 3 there just for my sketch. There we are. And let's just work up that value there when x is 3. So 2 minus 3 is minus 1. Minus 1 times 3 would be minus 3. So this is going to be at minus 3 there. And this now is my probabilities. This area under here, isn't it? But when you look at this section, this is when f of x is less than 0, isn't it? And we said that p.d.f, that it always had, the probabilities had to be positive. So that f of x always had to be positive. Therefore, this is not a p.d.f. because f of x at one point is less than 0, isn't it? You know, from x, when x is greater than 2, our f of x is less than 0. And obviously our f of x needs to be greater than or equal to 0 for the whole thing. So this is the first look at our PDFs and what kind of constitutes a PDF from just a function. Next, what we're going to do is move into an actual example. So here we have the random variable x, and it has probability density function given by this. So we use this to state what our probability density function is. So it's this function, but only between these values. Outside of this function, where we got 0, means there's no probability. Okay, so that's quite important. And this is the standard setup for when we're describing a PDF. So what we want to do here is, for part A, is first sketch it. So if we're sketching it first, we're sketching it in terms of k. If we had found the value first and then sketched it, we would sketch the value when the graph when we've actually found the value of k, if that makes sense. So just doing it in this order. So first what I'm going to do is a very rough sketch and look at our values. Now we've got a linear graph here between 2 and 4, so I only need to look at the limit. So when I substitute 2 in here, we get 4 minus 1 is 3, so 3k. So when x is 2, we're going to start at 3k. And then when x is 4, 2 4s are 8, minus 1 is 7, so it's going to be 7k. Now it's a sketch, so you know it doesn't really make too much difference, you know, in terms of the steepness of the graph and so on, because it's just, you know, whatever you want to use. And here underneath we will have our area. So that's our graph, but actually I'm going to get rid of that. I'm going to leave it like this. So we've got our graph here. Let's put our x in and our f of x at the top. So that's part A done. Now part B says find the value of k. Usually in this type of question, if I've already done the sketch, finding the value of k, it's usually easier to use the sketch because it's the area under the graph. And if this is linear, you know, I've got a trapezium. Okay, so in this case my area is going to be 3k plus 7k divided by 2 times the distance between them, which is 2. So we get 10k over 2 times 2, so it's going to be 10k. So we have 10k equals 1, so k is going to be equal to 1/10. Okay, now you could, if you don't like trapeziums, I suppose you could actually split this into a rectangle and a triangle, triangle and rectangle. And area 1 here would be 2 times height 4, isn't it? 4k divided by 2, so that's 4k. And area 2 is the rectangle, which is 2 times 3k, which is 6k. So you can see the total area here is still 10k. And then you can say that k equals 1/10. So you do have a couple of options, you know, if you don't like using trapeziums, or I know some people, especially when you're looking in terms of k and graphs like this, they often make mistakes with trapeziums. So you could split it up into a rectangle and a triangle. totally up to you. Now all that's left is part C, to find the probability when x is less than 3. So all that is the area on my graph when x is less than 3. So and there you have it. So there's 3, less than 3 is between this 3 and 2. So I can find the area between this. We already know what k is in tenths. So, we've got a distance. Oh, sorry, let's do the height first. So we've got this height, a plus b. So if I'm looking at that, that's 3/10 plus, and then we have this height. So this height, remember that this function now is basically 1/10 on the outside, which is my k, 2x minus 1. So if I substitute 3 in, we get 2 3s are 6, 6 minus 1 is 5, 5/10 or 1/2. I'm going to put 5/10 down here just as it's easier when I'm adding. And I jumped a little bit ahead there, but times 1 because the distance here is 1. So we got 8/10 divided by 2 is 4/10 times by 1, still 4/10 or 2/5. And there we have the area under the graph between 2 and 3, or where the probability of x is less than 3. Now there is an alternative way of doing this, and that is by integrating. So I could integrate between 3 and 2, and what I'm trying to find here is of 1/10 2x minus 1 dx. Okay, and this is obviously the probability where x is less than 3. So this is what I'm doing. I personally do like to take the 1/10, that constant, outside. I just think it's a little bit easier when it comes to doing my integrating, and it makes no difference, but it's up to you whether you take it outside or not. But I'm going to take it outside, so that's going to leave me my 1/10. 2x is going to be 2x squared over 2, where the 2's will obviously cancel, and minus 1 is just going to be minus x, and then that's between 3 and 2. So here we have 1/10, and we've got 3x squared, which is 9, isn't it? But 3x squared minus 3 minus 2 squared minus 2. So that means we have 6 minus 2, which is obviously 4/10, which we know is 2/5, and the same answer as over here. What I would say is, personally, I'd be using the area under the graph in terms of its shape, if it's something linear and straightforward. If it is something that's like a quadratic or a cubic, as you'll see in a later example, then the integrating really is the only way to go. You can use the integrating the whole time, but as you can see here, it is quicker in general to use areas of shapes if we're dealing with linear functions. So here we have a very similar example to the last one. What you will notice is that in this one, my f of x has 2 functions essentially. This first one, which is simply k, is between 1 and 3, and then my second one, where we've got k brackets x minus 2, is between 3 and 5. So for my p.d.f, I've essentially got kind of 2 graphs, if you think of it that way, or 2 functions stitched together. That's probably the easiest way to think about it. Now, part A is to sketch, and since it's asking me to sketch before finding k, I should sketch in terms of k. That's what I would say is the kind of general rule when you're looking at these. So we've got k between 1 and 3. So if I think of 1 and 3, pick a position for k, and it's just going to be a horizontal line. This is like drawing y equals 3 or y equals 2, y equals 1. It's just y equals k. Now for my second one, you can see here then we're between 3 and 5. Now if I substitute 3 in, we get 3 minus 2, which is 1, 1k. So it's actually going to start right here, which is where the other one finished. And that, I would say 99% of the time, is how these work. And it's going to be linear. We're going to finish with 5. So 5 minus 2 is 3, 3k. So if I think now up to about 5, we're going to go up to somewhere like this, straight line, and that's going to be at 3k. And that there is my graph, or my p.d.f, I should say. So that's f of x, and that is x there. And then part B is finding k. So as we've talked about before, we can do this by finding the area under that p.d.f. So this area here, or we can do it by integrating. Now in this case, if I was doing it by integrating, you would, obviously this is actually quite a straightforward area to work out, but if this was more complicated, I'd be integrating between 1 and 3 for my first function and 3 and 5 for the second function there. Obviously, like I said, it's far more complicated. It's far easier to find this, just the area. So if I look at this first area here, that's simply, and I'm going to call that, area 1. So this area 1 is just going to be a rectangle. So it's got a length of 2 and a height of k. So area 1 is just 2k. Area 2, in fact, now I'm doing this, I'm actually going to take a little step back. Let's get rid of what we were thinking of area 1 and area 2 here. Let's get rid of that. And making it a little bit easier, if I think of spreading this across here. And let's think of this as my area 1, because then it's a large rectangle, isn't it? So my area 1 is going to have a length of 4 between the 1 and the 5 and a height of k. So it's 4 multiplied by k, or 4k. And area 2, let's actually do that in a different color. So let's go area 2. It's going to be this purple here. That's a triangle now, isn't it? So base is going to be between 3 and 5, so it's going to be 2 times height. That's between 3k and 1k, so it's 2k. And of course we're dividing by 2. So that's going to give me a total of 2k there. That means my total area is 4k plus 2k, which is 6k. Now I know that, and I know that the area must equal 1. So since my total area equals 1, we get 6k equals 1, k equals 1/6. Now we're just left with part C, greater than 4. Just before we do that, I'm just going to pop in, the 1/6 in here, just for us. So greater than 4 means it's got to be in this part. Yeah. So if I'm going to integrate, I'm going to integrate only this bit, not this first part. So if I think of part C here, and I want to find the probability where x is greater than 4, what that means is I'm going to integrate between 4 and 5, because anything outside of this 1 to 5, so 5 and above 5, below 1, that's going to have a probability of 0. That's what that otherwise means. We've got 1, 6. I'm going to put that on the outside. You know I like to do that. And we've got x minus 2 dx. So let's look at now integrating this. And this will give me 1 over 6 x squared over 2 minus 2x, and of course this is between 5 and 4. Now I'll skip ahead here and just put the answer down, as I don't think you need me to keep showing you how to substitute numbers into things. So the answer is 5 over 12 there. Of course you can also use your calculator to do this, or at least to check it out from here. Final example here. This time we've got an x squared, a quadratic, and that's going to make it a little bit more difficult. We can't find k the way we've been finding k in the previous questions. Okay, previously we sketched and used the shapes. This one, you know, the clue is in the question. It's asking us to find k first before sketching, and that is exactly what we're going to do. So the first thing I want to do is, I know that the total area is going to be equal to 1, isn't it? So if I'm integrating my k, now k is a constant, so I can put that just outside. And I got x squared minus 2x plus 2 dx, and that's between 0 and 3, as those are my limits. Plus, and then we're going to integrate the 3k between 3 and 4. Again, that is only a constant, so I might as well put it inside. And this totals 1. So that will leave me with k x cubed over 3 minus 2x squared over 2, which 2's will cancel, plus 2x. And secondly, then we get 3kx, and that was between 4 and 3, and of course this totals 1. Now it's quite obvious when I substitute 0 in that this is 0, this is 0, this is 0, so I can just deal with the 3 there. So if I substitute 3 in, we get 3 cubed over 3 minus 3 squared plus 6. Sorry, minus 3 squared there. So that's going to give me 9 minus 9 plus 6. That's going to be 6k plus, and then when I substitute 4 in here, we get 12k. And when I substitute the 3 in, we're going to get 9k. And of course that one is minus 9k. Yeah, just because obviously it's the 4 minus the 3. So that's 12k minus 9k is 3k plus my 6k, so that's 9k in total, equaling 1. Therefore k must be 1/9. Now that we've found k, we can go ahead and sketch. So as before, let's set up our quick set of axes. And our first one is going to be a quadratic. It's a positive quadratic, so you should have an idea of the shape. Start by substituting 0 in, so we get 0, 0, 2, and obviously k is 1/9. So that's going to be 2/9. So we know that's a positive number, don't we? There. And then when we look at moving across, so if I substitute in, say, 1 in, we get 1 minus 2 minus 1 plus 2 is 1. 1 times 1/9, so it is going to be just 1 is going to be slightly down there. If we think of moving across to 2, 2 is going to be, 4 squared, sorry, 2 squared is 4 minus 4, back up to 2, isn't it? So that's going to be, 2/9 like that. That's the bottom of our quadratic there, isn't it? And then up to 3, we're going to get 9 minus 6, which is 3 plus 2 is 5. So 5/9. So if we think of our 0, 1, 2, 3, by the time we get to 3, we're looking at 5/9 there. And then at that point, what we've got is just a constant. So a constant is just going to be a horizontal line. Obviously 3 times 1/9 is 1/3. So on this one it's going to be just the height of 1/3, okay, or 3/9. So that's going to be something, say, like that. So what we've got is a little dash there from 3 and then to 4. Made that a little bit big, haven't I? Let's get rid of that. And there's 4. Okay, so that's what we've kind of got now as a rough sketch of this PDF. Now don't forget to pop in your f of x if it is f of x and x, or f of y. But what you'll notice is, and I did say this previously, is that 99% of the time this value of 3, this value of 3, when you substitute in here and substitute in here, it's often the same, but it's not always the same. Okay, so you can just put some dashed lines if you want. You don't have to put anything. You just, the bold lines is what you need. Sometimes what you will see, and I'll pop this in red here, but sometimes what you'll see is a line going off outside of the actual PDF to show that that is a value of 0. But again, it's not necessary, but you might see it. And then finally, part C, we are looking at finding the probability between 2.5 and 3. So 2.5 and 3 happens here, so it's just this part. Just incidentally, if this was, say, between 2.5 and 4, you know, you would have some of this and all of this, for example, in terms of its area. So you know that area straight away, and you just have to work out some of this area. Okay, but we're just looking at between 2.5 and 3, so the easiest way is to integrate. We know we've got 1/9 as our value of k, and that's x squared minus 2x plus 2 dx. Now we've actually already integrated this over here, haven't we? So we can use this just to help us out and just jump. I'm going to just jump straight down here with the answer. And I get 49/216, or that could be 0.227 to 3 significant figures. So either answer would be acceptable there. Hopefully that's given you a good insight into the PDF. I've set up 4 questions for you, and as always, I'll go through the answers at the end. Hopefully you enjoyed watching and found this video useful. If you did, don't forget to like, subscribe if you haven't already, and comment down below.